So here's a graph that represents the value of a car in thousands over a decade. So here's our graph. It says, by what factor did the value of the car decrease in the first decade and a half? So again, we're switching units. We're talking about a decade, and now it's asking about a decade and a half. So we're going to look here, and remember, when we're finding the rate, if we're given two numbers like this, we do the first number on the bottom and the second number on top, and we divide those two. So we're going to divide 1.25 by 10. So when we do that, we put it in our calculator, or you could just do it in your brain, and you get 1.25. All right, my mouse is being a little silly. So that 1.25 is for every decade and a half, because if you look carefully, this is going from 0 to 1.5 decades. So this is 15 years we're talking about. So this is really over 15. So if I wanted to find 1 year, I would need to divide it by 15, because that would be a decade and a half would be 15 years. So for A, it says, by what factor did the value of the car decrease in the first decade and a half? So this is just asking for the whole decade and a half. This is just asking for the 1.25. So this is the 0.125. And we know because we divided the two numbers together. So where it says explain how you know, just have that written down there. All right, so that's going to be the first decade and a half. That's the rate it's decreasing by 0.125. So then by what factor did the car decrease in the first half decade? So when we're looking at this, this is a decade and a half, which means it's 15 years. If they're talking about a first half of the decade, that means that I'm talking about 5 years. So I can put 5 up here. That would be the first decade, or the first half of a decade. I could also reduce that and do 1 over 3. So either way would work. So 0.125 to 5 over 15 or 1 over 3, whichever way you like it in your brain, you can do it. And then we'll go to our calculator and we'll put that in. So 0.125 to the 5 over 15. Just remember to put it in parentheses, or if you like it 1/3, you could do 1/3, and you can see that you get the same answer for both of them. Oops, not 13, 1/3, and you get the same thing, 0.5. So when we're doing this, the first half decade has a rate of 0.5. And then it says, what about the first decade? So now they're changing it from a half a decade to a decade, which is 10 years. So now I need to change this 5 to a 10. And then I could do the same thing, put it in my calculator. I could do 10 over 15, or I could do 2 over 3, again, whichever way your brain works. So I would do 10 over 15. Or I could do as my exponent. All right, but either way, I get 0.25. All right, so my answer for this one is 0.25. And again, you would include the work to explain how you know. All right, now it says write an equation relating G. So we know that's G, the value of the car in thousands, to decades. All right, so now we need to write the equation, and it's talking about decades. So remember, the first value is the initial value. That's what goes here is the initial value. We look at our graph, our initial value is 10. So it's 10, and remember it's in thousands, so it's not really just $10. The car is $10,000. Then we do our rate. Now this is where you have a couple options, because it says in X decades. You can use the decade one, you could use the decade and a half one. It's all up to you how you want to do it. So if you use the decade one, I think that's the easiest one, because here's our decade one, we just found the answer, is that you could just do 0.25 to the X. All right, but if you wanted to use the decade and a half one up here that you did here, you could do that one too. But I think this one's the easiest one. If you did do the other one, you could do the G to the X. It's still the same initial value of 10, but if you wanted to use the initial rate we found of that 0.125, and then we found it by doing 2/3, so you would have it over 2/3, and then you need the X to go on the top. So either one of them is correct, whichever way your brain works. I think this one's probably the easier one because we already found the rate for a decade. But if your brain works the other way, that works too, and that's the right answer. All right, number 5. So this one says a sample of nickel 63 has a weight of 9.8 milligrams and have a half-life of 50 years. So remember, a half-life means that it gets cut in half. So just to make it easier, if it says it's 100 milligrams and a half-life in 50 years means that 50 years later, it's not going to be 50 milligrams, and then 50 years later, it's going to be 25 milligrams, and then 50 years later, it's going to be 12.5. So it keeps getting cut in half. All right, so for A, it says how much of the sample will remain after 50 years? Oh, sorry, my light just went out. So we just explained that the 50 years is telling me how long it takes to get cut in half. So if in 50 years it gets cut in half, all I have to do is do 9.8 divided by 2 because it's 50 years, it got cut in half. So I would do 9.8 divided by 2, and I would get 4.9. Sorry, I want to turn my light on. 4.9, and then don't forget to write milligrams. 4.9 milligrams, right? Because it takes 50 years to do the half-life, so it's getting cut in half. So now it says in 10 years, how much is going to remain. So this is where we kind of need to think back to what the factor is. So the factor is it's getting cut in half. So our factor would be it's getting cut in half, and it's every 50 years. So that means that needs to be our denominator. Every 50 years. Sorry, I know that's hard to read. It's 50. Every 50 years. So now if I want 10 years, I'm going to put 10 in my numerator, and that will be 10 over 50, or you could reduce it to 1/5. So then we would go to our calculator. We plug in 1/2. Oh, it's asking for the whole sample. So we want to do the initial amount too. Sorry, that was my fault. So 9.8 is the initial amount. The rate is 1/2, and it's 10 divided by 50. Oops, not 40. Divided by 50. So 8.53. All right, so let's go back to the problem. All right, and here's our calculator so we can see what I typed in. So because it is asking for the actual amount of sample, that's why I needed to include the initial part. So I needed to include the 9.8. All right, so here's what I typed into my calculator, 8.53. Then I can just round to that, 8.53, and don't forget milligrams. 53 milligrams. All right, and then 1 year, all I need to do is change this 10, because now I don't want 10 out of the 50 years. I just want one out of 50 years. So I just want 1 out of 50 years, so it's 1. So I'm going to type the whole thing back into the calculator, 9.8. 1/2 because it's a half-life, and my exponent this time is 1 to the 50th, and I get 9.665, so I would write 9.67. Then let's go back to our work, and I would do 9.67 milligrams, which makes sense because if it takes 50 years to get cut in half, 1 year is not going to do much, so it's not going to change much from the 9.8 to 9.67. Right, and then it says to find the model, the amount of nickel F of T remaining after T years. So this is perfect. We just wrote the equation down here in this box. So we're just going to change it to be F of T. Here, we have our initial amount, we have our rate. This, remember, was 1 out of the 50 years. So they're just asking us to use T, so that way I could say 8 years or I could say 12 years. You could just plug it in for T. You would just change this to a T. It would be T over 50. All right, so those are the first 5 questions for the first day of your quiz. If you're in my class, I think some of the other teachers are splitting it differently. And then the next review will be the next video.